geometry. We'll talk about conditional statement. We're going to then do some examples on it. We're then going to deal with inverse, converse, and contrapositive of statements. We're going to talk about biconditional statements. You're going to mind your P's and Q's. And we're also going to discuss law of detachment and law of syllogism. All right, so let's get down to this. So you can hear that. That's my dog. A statement that can be written as an if, then. So this goes right here. So it's an if-then form. The symbol for this is P to Q, and implies, so if P then Q, or P implies Q. Let's see what it gives us here. Hey, that's exciting. So keep going. So when you're thinking about science, think science, guys. The blank is the phrase immediately following the word blank. So the hypothesis, following the word if, right? And then the conclusion is the phrase immediately following the then. Okay, so trying to do the examples. You're going to identify the hypothesis, okay? And then you're going to do the conclusion, right? And the actual conditional statement is what you start with. So your hypothesis is, remember, it's going to be right after the if, but right before the then. And then your conclusion is going to be what's after the then. You're not including the then. Okay? You're not including the if. So the hypothesis is going to be you live in Nashville. The conclusion is you live in Tennessee. Literally, that's it. So you guys try 2 and 3, pause the video, try 2 and 3, and then restart. Okay, so hopefully you got those as your answer. I'm going to keep going, so if you want to write those down, you need to pause the video. So down here, writing conditional statements, write the following statements in if-then form. You have to remember, and let's go back up here for a second. I'm going to write it right over here. I'm going to write it over here, okay, what I'm going to say. So the way this works is you have to state the if, you then have to state You know what? Hold on a second. I want to do this differently. So what you want to do is you want to do the if first. Then you need to state the object. Then what you can do after that, by stating the object in the beginning, you can then say it, or they, or mostly it, to be honest. You, anything that's a pronoun, okay? So with that said, okay, with that said, let's go down here and write these like number 4. So an obtuse angle has a measure greater than 90. So with this one, the obtuse angle is your object, okay? But you don't want to use the describing part of the angle. So you're actually going to just use the angle. For some reason, this is not working very well. So that is your object. So if an angle, you got to state the object first, is obtuse, then if there's your reference to the object, it has a measure greater than 90 degrees. What the heck? That was odd. So okay. So again, here's your object that you're starting with. Okay, and this is referencing back to the object. So I want you guys to try 5, 6, 7, and 8, and then turn it back on. So I wanted to point out something here. All numbers divisible by 4 are also divisible by 2. You need to make sure you remember that you take the bigger of the two. So being divisible, I'm sorry, looking at number 4, obtuse is a bigger idea than being greater than 90. You have to describe the object just so you can use the word it. Okay, pause it again. So if you look at, I don't know, let's see, number 8, and it says prime numbers only have 2 factors, one in itself. The word prime is bigger than stating 2 factors of itself. Okay? Okay, so the inverse. Formed by negating the hypotenuse and the conclusion. So when you read something, you just put not in there, somehow saying that it's not happening. The converse, you're just switching. You're switching the hypothesis for the conclusion. Simple as that. Contrapositive is formed by negating and switching. So as you go up in words, you kind of get longer and longer. Yep. The longer the word, the more stuff you have to do to it. So formed by negating and switching the hypothesis and the conclusion. That little symbol means you're negating it. All right, so let's look down here, example 1. And we're going to write all the different ways for this to happen. So if it is Saturday, then there is no school. So we're looking at the inverse. We go up, and all we want to do is negate both sides. So if it is not Saturday, then there is no school. Okay, so is that true or false? If it is not Saturday, then there is no school. Think, think, think. Hopefully. It's false, and then give your counterexample. Remember, you got to give the counterexample. Okay? Got to give the counterexample. So what day of the week? Sunday. Okay? Now, the converse, which is just switching the hypothesis and the conclusion. So I'm going to type it right there. Now, is that true? Is that true? If there's no school, then it's Saturday? No. That's also false. Because again, you could have it could be Sunday. For the contrapositive, we need to negate them, but also switch them. So if there is school and it is not Saturday. So if there is school, then it is not Saturday. Is that true or false? True. All right. I'm going to go to the next page. All right. So now that we got, I know you didn't see it, but now that I got that malfunction of my computer, the definition of a biconditional. The conjunction of a conditional and its converse. So if you've got P to Q and Q to P, it reads as P if and only if Q, which this. Okay, and then the biconditional statements are true when both the conditional and the converse are true. So for number one, it states that given the biconditional statement below, write both the conditional and converse. Determine the truth value of the biconditional. Explain why or why not. So two angles are supplementary if and only if the sum of their measures is 180. So you have to figure out what's the object and then what's bigger than the other. So for example, your object are angles. Two angles are supplementary, so is supplementary bigger or is the measure of 180 bigger? That's what you need to figure out. Whichever one you figure out is bigger needs to go in the if statement. So if two angles are supplementary, then what? Then the sum of their measures is 180. Okay, so let's look on this page number 3. X squared equals 25 if and only if x is equal to 5. So you're going to start this off, of course, with if. So if, what am I doing here? If x squared oops, equals 5, 25, then x equals 5. That's your conditional. Conditional is the if that. If and only if is your biconditional. So the converse, you're going to flip it. So if x equals 5, then x squared equals 25. All right, so is the top true? If x squared equals 25, then x equals 5. Is that true? Yes. If x equals 5, then does x squared equal 25? Well, if x equals 5, it could have any type of other answer, or x can have a different answer. So the truth value is actually false. And which part is the false? It's the conditional. X could be a negative 5. So you have to be careful in when you make these statements, because you have to be really, really careful about if you're, if one's true, the other's true, or whatever. Got to make sure that you really pay attention to what's being said. All right, moving on. Number 2 is false. Number 4 is true. Thought you guys would want to see that, hear that. Okay. So if we turn the page, we're now on page 20. Oops. Now on page 20. We're on page 20. So mind your P's and Q's. A graphic organizer for logic statements. Here's what I want to do, actually. This is going to be part of your homework. Now, okay, and we're going to label it mind your P's and Q's. Okay, what I want you to do is I want you to fill this out. Now, let's go back over. I'm going to do the left side with you. P conjunction is and. This junction is the or. So this is your and this is your or. Oh my goodness. All right. Sorry. So your conjunction and your disjunction. Let's go down. Your conditional is going to be your P to Q. I need arrows all the way down. And I need one for both. I don't have to do arrows anymore. Okay, so let's go up here. So we have P to Q. Our inverse is going to be your not P to not Q. Okay. And then for your converse, it's going to be Q to P, if you're reversing it. And then your contrapositive is where you reverse it, and then you also put your knots in there. So not Q, not P. Don't know why. Okay. Biconditional is just your P to Q. All right. Now, with all of that written down, all right, so now that I have all that written down, you need to go through and you're going to use this right here. Okay, to write all that down. All right, and then we're going to check it for first period. We're going to check it on Monday. Oh, both periods, first and second, we'll check it on Monday. You guys got to do this. If you can fill this out, then you will understand how to do your homework and all that good stuff. All right. So please, please, please either work with each other and get it filled out, or make sure you do it this weekend. All right, let's go to the next page. Okay, so deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. So when we talk about, we're going to talk about law of detachment first, and then we're going to talk about law of syllogism after that. Okay, so law of detachment is one way of doing deductive reasoning, and the other one is law of syllogism. So the first one is law of detachment. Given a conditional statement, if the hypothesis is true, then the conclusion is also true. One of those if by default. So their notation is P, Q, P, and then you have the therefore. Do you guys wonder what therefore is, I wonder? There's three little dots. I don't know if they're going to have it either. Insert, done. Therefore, Q. Turn it up into that arrow. So if P goes to Q and P is true, therefore Q is true. So this right here, so if P goes to Q and P is true, therefore Q has to be true. Okay. So for the use the law of detachment to give a valid conclusion. If possible, write no valid conclusion. If Mark saves $30, then he can buy a new video game. Mark saves $30. wrong? Mom, what's wrong? I need you not to say anything. Okay, everybody, sorry about that last part of the recording. Making sure my mom was okay. So for number one, if Mark saves $30, then he can buy a new video game. So now Mark has saved that $30. So your conclusion can be Mark can buy a video game. For number two, if a quadrilateral is a rhombus, then it is also a parallelogram. Quadrilateral ABCD is a rhombus. So you're assuming that the hypothesis is true, therefore the end of it, which is the conclusion, is true. So if I give you this statement right here in class, if a quadrilateral is a rhombus, then it is also a parallelogram. And then I tell you guys, okay, go away, go out of my classroom, and I see you on, down in the lunch table. And I walk up to you and say, oh, hey, by the way, quadrilateral ABCD is a rhombus. You then can then say to me, because you remember the green sentence that I just circled. If something is a rhombus, then it's got to be a parallelogram. So what can you conclude on number two? Quadrilateral. And yes, you have to state it. A, B, C, D is a parallelogram. So, as you can see, by using the first statement, if a quadrilateral is a rhombus, we're saying that's true, then it's also a parallelogram, we're saying that's true. And then I give you a card that states this, that the quadrilateral ABCD is a rhombus. You can then say, oh, the rhombus, then it's got to be a parallelogram. Okay, number three and number five don't have a conclusion you can make. So if we just look at number three, if you are 18 years old, then you can register to vote. Olivia is not 18 years old. What does that tell us? Nothing. We don't want to know anything. Guys, I'm really, really sorry, but this is what happens when you live with your mother. She lives with me. Oh boy. Okay, looking at number three again. If you are 18 years old, then you can register to vote. Olivia is not 18 years old. She's not 18. Do we know anything about anybody that's not 18? No, we don't know anything about them. So we can't conclude anything. So there is no valid conclusion. Okay? All right. So, what we got next? Law of syllogism. All right. This one I call leapfrog. Yay, back to leapfrog. Back to the leapfrog. Okay, so law of syllogism allows you to draw a conclusion from two conditional statements in which The conclusion of the first statement is the hypothesis of the second. Okay, so there's the symbolic map. So this is what I mean by leapfrog. You start with P, and it goes to Q. Q drops down as your leapfrog, and it goes to R. So you get rid of the Q's in the center, and you get the P and the R. All right, number 6. Number 6. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So if you look right here, those are identical. So it wants you to use the lost syllogism to give a valid conclusion. If not right, not valid. So what you're going to do is you're going to literally not write this because it's already in both of those statements. So the statement reads, if it is Saturday, then he, it's got to say Jake. Then Jake will need to pack his lunch. Okay, so if you can drop out the center, then you got it golden. So if a number is divisible by 12, then it's divisible by 6. If the number is divisible by 6, all right, so we can get rid of this. Now we have our two statements. Number 8, if a quadrilateral is a square, then it is a rectangle. If a quadrilateral is a rectangle, then it has 4 right angles. That crosses out. And now you've got your statement. So if there's something that actually duplicates, then you're good, but it has to be conclusion to a hypothesis. So for example, number 9, if it's sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. This right here and this statement right here have to be the same, not the other way around. Okay? All right. For practice, and I think that's it. Okay, so your homework for this weekend is the following. Just lost my piece of paper. Okay, so your homework for this weekend is homework 5, which you see right here. Okay, and you're going to do all. And then homework, I don't know, let's see what it's there. Oh, that was pretty good. Homework 3, you're going to do all. You're going to also make sure you remember to do the graphic organizer that I told you guys about. On page 20. Okay. So homework 3, homework 5, and then this page 20, which is mind your P's and Q's. All right, guys, that's it.